And welcome to our Chapter 10, Module 3 Team Teach. And we're going to go over a few of our homework questions. And my name is Sarah Vernick.
I'm Demia Hendricks.
I'm Courtney Snyder.
And I'm Taylor Richardson.
Okay, Sarah, can you tell me what is 1 gallon equivalent to?
Sure. So we have 1 gallon here, and we want to know what is it equivalent to so we can eventually fill our pail up. So 1 gallon is equal to 2 bottles. Okay, Courtney, how many mouthfuls are in a pint?
Thank you for that question. Using the given things we have over here on this side, we can figure out how many mouthfuls are in a pint. What we're going to start with is we see that there are 16 mouthfuls in 1 cup. And 1 pint over here is equal to 2 cups. So we are going to double the mouthfuls to equal up 2 cups. So we have, well, it's supposed to be 32 mouthfuls to 1 pint. It's written down. I apologize about that. But it is 32 mouthfuls to 1 pint.
Thanks.
Would this empty pail overflow if we were to add each of the following measures to it, Taylor?
All right, we're going to look at this question about this empty pail, and we are going to see if it would overflow if we put all of these, one of each of these measurements into this pail. And so in order to do this, it's important to know how much each of these measurements is. But this is actually more simple than it looks, because the way that these increase is in what is called a doubling system. And what this means is that for one of each of these, they will equal 2 of another one. So for example, 1 jigger is equal to 2 mouthfuls. 1 jack is equal to 2 jiggers. 1 Jill is equal to 2 jacks, and so on and so forth. And so when we're looking at this, we know that we're looking at a pail, and 1 pail is equal to 2 gallons. And so when we add 1 gallon to the pail, it's going to take up half of the pail. And when we add 1 bottle, we know 2 bottles equals 1 gallon. So 1 bottle is going to take up half of that space that we have left. And it's going to keep going just like that. 2 quarts is equal to 1 bottle. So 1 quart will take up half of that remaining space. And then a pint will take up half of that remaining space. And then 1 Jill, 1 jack, until we finally get down to 1 mouthful. And we know that when we add all these up, we're still going to have room for about 1 mouthful left over. So it's not going to overflow. How many bottles will fit in a pail?
Okay, I'm glad you asked. If you look at the bottom here, I have like a little rectangle for the pail. And if you're paying attention, you already know that 1 gallon equals 2 bottles. So if you double that and you have 2 gallons, you'll get 1 pail. So if we start here and we have our pail and we add our bottles until we fill up, we'll end up with 4 bottles fitting into 1 pail. Taylor, which of these contains 16 mouthfuls?
To find the answer to this question, we need to understand the system of doubling that occurs with these measurements of capacity. When we look at this chart here, we can see exactly how these measurements play out. Because there are 2 mouthfuls in 1 jigger, we can know that there are 4 mouthfuls in 1 jack, because 1 jack is equal to 2 jiggers. Because there are 8 mouthfuls in 1 gill and 2 gills in 1 cup, we can deduce that there are 16 mouthfuls in 1 cup. So the answer to this question would be 1 cup. Sarah, what is the area and perimeter of this triangle?
All right, before we figure out what the area and perimeter will be, we need to know that the perimeter is the measurement of all the sides added together, and the area is going to be the base times height times 1/2. Let me see if it will. See, I'm trying to get it to show up here. So for our area, our perimeter, we're going to take 8.5 plus 6.2 plus 3.1. And the reason why we're not going to add the 2.6 is because that's not, I mean, it shows it as height, but it's not the correct height for our triangle. So, and our area, it shows right there, but our perimeter, let's finish that one, it's going to be 17.8 centimeters with all 3 sides added together. So to find the area is 1/2, which is also 0.5 if you're doing on the calculator, times our base, which is our 6.2. And this is what we're going to use this 2.6 over there on the corner. So that's our height of the triangle. So when you multiply it together, we're going to get 8.06 centimeters squared. And anytime you find area, your unit of measurement is always going to be squared. All right, Courtney, how do I find the area and perimeter of this triangle?
For this triangle, what we're going to do is we see right here this line coming from the middle of our base. Well, not really the middle, but it's where we go from the highest point in the triangle and we bring the line down to the base of our triangle to create a right angle. That is our height to know the area of this whole triangle that we're trying to find. So for the equation to find the area, it's 1/2 times base times height. So we're going to plug in our numbers. Our base is 82.3 and our height is 41 meters. So when we put that in, we'll have 1/2 times 82.3 times 41, and our whole area is going to come out to 1,687.15 milliliters square, or meters squared, I'm sorry, and that is this whole triangle right here. Now to find the perimeter, we don't need this middle number right here that is in our height. What we're going to do is add all 3 sides together. So it's going to be perimeter equals A plus B plus C, which is just the 3 sides to the triangle. So when we add all those together, our perimeter is 199.3 meters. Taylor, what is the perimeter and how can I find the perimeter of this shape?
The perimeter of an object is simply the total measure of all of the sides of an object. To find the perimeter of a shape is really simple. All you need to do is simply add up each length of each side of the shape. So when we're looking at this shape, we have a polygon with 5 sides, and what we want to do is add up each side. So we would add 9 plus 8 plus 6 plus 5 plus 4, and we would get that the perimeter of this shape is 32 meters. Demia, how do you find the perimeter?
Okay, so when you're looking for the perimeter, you're going to add all sides of the shape. Okay, so for an example, you're going to do A plus B plus C. So it never really matters what you consider your A, your B, or your C as long as you add all sides together. And then in this particular one, we made 48 our A, 69 our B, and 82.3 our C. And if you add all those together, you get 139.3 meters. And that is how you find your perimeter. Courtney, how do I find the height to solve this problem?
As I was saying in my previous slide, your height is what you want to find from your base all the way up to your highest point, making a right angle. Now this triangle right here you see does not have a right angle in it. So what we're going to do is we're going to create our own. So we just extend the base, this bottom portion out right here as a dotted line. We're not changing the triangle in any way. We're just extending the line out and then a line up to make our own right triangle. And this line right here is going to stop at the highest point of our triangle. And that measurement would be 2.6 centimeters. And that would be what we plug in for the height to find the area of this triangle. Sarah, what is the area of the smallest circle?
Okay, and so we're going to also remember that area is not the same as perimeter, so we're not going to add it. So to find the area, we are going to add up, oops, we're going to add what we have here. So we know that a circle equals pi times radius squared. So that's going to help us find it. So pi times 5 squared, and 5 is, the reason why we're using 5 is because 5 is half of 10, which would be our radius, because radius doesn't go the full way. It's just from the halfway point or the vertex to the outside edge. So if it says it is 10 units, it's going to be 5 because it's half of that. 5 squared is 25. So we get 25 pi units squared, and that's going to be the area of our smaller circle. Okay, Demia, how do you find the area of a region between the circles?
Okay, so when you're looking for the area of the region between the circles, you're going to find out their difference. So basically you subtract what you have from two circles. So here we have two circles, one circle being 100 and one being 30. And just to give you a visual of what you're looking for, I have the two arrows showing in between the circles. So when you subtract the two, you end up having 70. So the area of the region between these two circles will equal 70.
Okay, thank you.
What is the area of the bigger circle, Courtney?
Now to find the area of the bigger circle, we don't know the diameter or the radius of the bigger circle. We only know that the square inside is equal to 10 units on each side. So to do that, we're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. Now we already know that this side right here is 10 units long. To get this side of the right triangle, we're going to cut it in half, and it's going to be 5 units. And we already know that this line right here from the center of the square to the outer edge is also 5 units. So we plug the 5 into the A and the B, and the C is this long line over here, or the hypotenuse of the triangle that we're wanting to figure out. So when we plug it in, we'll get 25 squared plus 25 squared, or 5 squared plus 5 squared equals c squared, which would be 25 plus 25. So our radius of this big circle would be 50. And then we would just plug it back into our formula for the area of a circle, which is pi times 50 squared. And it would come out to 7,853.98 units squared. Can you identify the different shapes in this figure and provide the formulas to find the areas?
I'm so glad you asked. As we have seen, there is not just one universal formula to find the area of any and every shape. So it's important for you to be able to identify different shapes so that you can be sure to use the correct formula. Here we have 2 circles and a square. We're going to start with the circle. The formula to find the area of a circle is pi r squared, r being the radius of the circle. The square, to find the area of a square, we're going to use a equals a squared, a being the number of sides that are within the square. Courtney, how do I find the volume of the cone?
Now, to find the volume of the cone, we're going to use the formula 1/3 times pi r squared times base times height, and our base area being pi r squared. Now, this is, oh, that one part didn't go away. Sorry about that. This is the figure that we're wanting to find, just this triangle and then our base right here. Our base is 2r, and our height is 2r, and base is our radius. And we plug it in to here, and the volume of the cone will be 2/3 VR squared. How do you solve for the radius of each volume object?
Yes, okay. So if you look at our shapes here, we start out, we have 3 different shapes, and we have a cone, a sphere, and a cylinder. So when you're looking at the volume of the cone, you're going to do V equals 2/3 pi times r cubed, and you're going to divide that all by 2/3 pi r cubed. So if you look at that, you're dividing it amongst itself, and then you're going to get 1. So that's your volume for the cone. And then for sphere, you're going to do volume equals 4/3 pi times r squared divided by 2/3 pi r squared. So if you look at that, you're kind of dividing 4 by 2. So if you're dividing 4 by 2, you know that you're just doing 4 divided by 2, you'll get the number 2. And then as far as the cylinder, you're going to have volume equals 2 pi r cubed, all divided by 2/3 pi r cubed, which is going to equal 3. So if you look at all 3 of these, you're going to get a 1:3 ratio. Sarah, can you tell me, how do you find the volume of the circular cone, the cylinder, and the sphere?
Yes. So we have a shape inside of a shape inside of a shape, and it looks kind of complicated, but it's really not. So when we start to find the volume, we want to know, well, we're going to start with the cone first. So the volume of the cone is 1/3 times pi radius squared times 2 times radius. We can simplify that by 2/3 times the volume times radius squared. So that's how we find the volume of the cone. To find the volume of a sphere, we're going to do volume equals, because we're always going to start with V because we're looking for volume, equals 4/3 times volume times radius cubed. And notice it's not square, we're doing cubed. And then the volume of a cylinder, it equals, again, V equals pi times radius squared times 2 times radius. And we can simplify that a little bit to 2 pi radius cubed. And we can simplify that again. We're not simplifying, but we're just have to kind of reduce it. I guess it's simplifying. 6/3 pi radius cubed. And one last time leaves us with 2 times pi times radius cubed. All right. And let's see, Courtney, what is the surface area of the shape?
Surface area is the area on top of that covers the entire shape. The shape that we have right here looks kind of like a slice of pie, and all we're wanting to know is what the surface, or how to find surface area. Now, surface area, you're going to find the area of this rectangle right here, and then find the surface area of the triangle, and then you'll just add them together. How do you find the surface area to a triangular prism?
Okay, so first let me start by showing you what is a triangular prism. So this is our triangular prism. And to find the surface area, you're going to always do 2b plus ph, which is basically 2 times the base plus the perimeter times the height. So if you do half of base times height, you end up getting 1/2 times 15 times 7, and then that gives you 52.5 meters squared. So if you look down here, basically all you did was you plugged in your numbers for each one to get your surface area. And then for the For the perimeter, you're going to add all the sides. So you have 15 plus 7 plus 8, which will give you 40. So then you're going to go back and you're going to plug everything in for your surface area, and you'll do 2 times 52.5, which is the base that we already did from over here, plus 40, which is the perimeter, times 7, which is the height, and it's going to equal 385 meters squared. Sarah, can you tell me what's the surface area?
Yes. So the surface area of this shape, and again, we're going to start by using our formula. So our surface area is going to be 1/2 times base times height, and our base is going to be 60 meters, and our perimeter is 40 meters, because again, like Demia said, our perimeter, we're going to add up our measurements around the shape. So then our surface area, our equation is 2 times base plus perimeter times height. We're going to substitute our measurements in. So we have 2 times 60 plus 40 times 7. And we're going to get 400 meters squared for the surface area of the shape.
Thank you.
And Taylor, what is one way we can find the volume of the shape?
To solve this problem, we are going to use this formula that looks a lot more complicated than it is. It is volume equals pi r squared times h1 plus 1/3 pi r squared times h2. h1 and h2 are the heights. R is the radius. R equals 2. h1 is the height of the cylinder, which is 10. And h2 is the height of the cone, which unfortunately is unknown. So we have to find that out. In order to find that out, we're going to use the Pythagorean theorem. And when we solve that, we find that the height of the cone is equal to 5.66 meters. Now that we know the values of all of our variables, we can simply plug in our numbers into our formula to find the volume. And we find that the volume is equal to 149.37 meters cubed. Sarah, what is the surface area?
Okay, so to find the surface area, again, like all of our problems, we're going to start first with our equation. And we're going to have 2 times pi times radius times height plus 4 times pi times radius squared. So we're going to take our 8 feet, which is, you can see it's in the circle. So that's going to be our diameter. To get the radius, we're just going to simply half that. So it would be 4. Our height stays the same. It's going to be 21 feet. So we're going to have 2 times pi times 4 times 21 plus 4 times pi times 4 squared. So when we put that in the calculator and do the math, we're going to get an answer of 729 feet squared for the surface area of this shape. All right, Demia, how do I find the volume of this shape?
Okay, so when you're looking at this shape, you see here that you have 2 different shapes. So you're going to look at them separately. So for the cylinder, you have pi times r squared times the height. So you have pi times 2 squared times 10, which will give you 125.6 meters. And then you have the cone, which is 1/3 times pi times r squared times height. So you're going to plug that in as 1/3 pi times 2 squared times 6, and you're going to get 25.1 meters. So when you add those together, your sum is going to be 150.7. Taylor, can you tell me what's the difference between surface area and volume in a shape?
All this talk about volume and surface area can no doubt get confusing. That's why you want to be sure to recognize when a problem is talking about surface area versus when a problem is talking about volume. To put them into perspective, let's look at this milk carton. The surface area of the milk carton is going to be the amount of carton, or the amount of cardboard that it takes to make the carton. And the volume is referring to the amount of milk that the carton holds. When you're talking about volume, it will always be represented in units cubed. like centimeters cubed, meters cubed, or inches cubed. And when you're talking about surface area, they will always be represented in units squared, like centimeters squared, meters squared, and inches squared. Thank you very much for watching.